So the question has come up about how to make sure that you can solve an augmented matrix and the steps to go through. And so I thought if I just did a screencast with you and kind of went through another one all on its own, that might help out the situation. So here you can see we have a two variable system. We have X and Y, and we're going to try and solve it using augmented matrices. So the goal, when we're all said and done, our goal is to have a matrix where you have 1, 0, 0, 1, because that's the identity matrix, where you have 1x plus 0y equals your x solution. And then on the bottom row, it would be 0x plus 1y equals your y solution. So that's what we're ultimately hoping for. So we're going to start by changing our equation into a matrix. And so we're going to look at our first row, which has 5x plus 2y equals 13. And so we're going to make that 5, 2, and then I'm going to draw the line so that you can see where your answer is supposed to go. So there's our first row. Our first row represents the equation in its entirety with just the coefficients of the variables and the answer. The second row is going to be the same thing. So we'll have -3, 1, and then -10. So the first thing that we want to do, the first step, is we want to change this 5 into a 1. So you always want to move, or you always want to alter the top left corner to make it a 1 so that you can do any manipulations you want with other rows. If you don't make this a 1 right away, it makes it more difficult when you're trying to change back and forth between rows. And then you end up going back in circles because you haven't made this a 1. So to do that, I'm just going to multiply the whole row by 1/5. It might not be the nicest fraction for the rest of the row, but that's just going to be the way it is. So then my next matrix, if I draw my arrow here, I will have my 1 in the leading position. This will now be 2/5, and this will be 13/5. And I'm just going to leave everything in terms of a fraction because if the decimals aren't nice, it will cause rounding errors at the end. We did not do anything with the lower row, so we're going to leave that completely alone. Step 2 is you're going to try and make sure that you get a 0 in the bottom left corner. So again, you manipulated the top left corner to get the 1. Now you want to manipulate the bottom left corner to get a 0. So in order to do that, we need to use some row operations. So we need to figure out what we can multiply row 1 by so that we add row 1 to row 2, we get a 0 in that lower left corner. So I'm going to multiply row 1 by 3, or -3. I'm probably going to do 3. So I'm going to do 3 times row 1 because then they're opposites, and then I can add that to row 2. So let's look at what that resulting matrix looks like. So I did not manipulate or change anything in row 1, so I'm going to leave all of those values alone. But in row 2 now, I have made changes all the way throughout. So if I multiply row 1, top left corner, which is 1, by 3, that's 3. Add that to -3, I'm going to get a 0 in that position, which is what I want. The next one is I'm going to have 2/5 times 3, which is 6/5. Added to 1 is going to be 11/5. And then 13/5 times 3 is 39/5. Added to -50/5 is going to give me, did I do that right? 39/5 minus 50/5, so that's -11/50. That's not correct, it should be fifths. Let me fix that. I don't know why I had that in the brain, sorry. There we go. And so now, if I look at trying to, let me make sure I did that right. So 39/5 minus 10, which is 50/5. Yep, that's correct. Okay, good. All right, so now if I look at my situation, now what I can do is I can try and simplify the bottom row. So the bottom row, I need to change my next step. So step 3 is going to make sure I get a 1 in this position. So what could I multiply that row by to change that into a 1? Notice that we're trying to just change that row, so you need to multiply by something, just like we did in the first step. In the second step, we needed to figure out a multiplication and addition so that we could change this into a 0. So when you're changing it into a 1, you can simply multiply a row by a number because you have an inverse property there. But if you're trying to get a 0, you need to be able to add to that row or subtract from that row. So I'm going to multiply row 2 by 5/11ths. And then I'm going to write my resulting matrix. So then I'll have 0, 1, -1. And I didn't do anything to the first row, so I'm going to leave that alone. Here we go. So now I have 3 pieces of my puzzle done. So notice what our goal was. Go back to your goal up here. Our goal was we wanted a 1 in the top left corner. We achieved that. Then we wanted a 0 in the bottom left corner. We achieved that. And then we wanted a 1 in the bottom right corner. So now all that we have left to do is to get a 0 in the top right. So again, remember when I said we were trying to get a 0, we need to multiply a row by something, then add it to the row that we want the 0 to appear in. So what can I multiply 1 by in row 2 so that when I add it to 2/5, I get an answer of 0? Right, so I'm going to multiply the bottom row by -2/5. Let me put that where it belongs. Hang on just a second. There we go. I'm going to multiply the bottom row by -2/5. And I'm going to add that to row 1. So notice I'm writing what I'm doing in the same horizontal row as what is going to be manipulated. All right, so let's see what we have for a resulting matrix. So we have the 0 and the 1 in the second row, and we have a -1. Now if we look up on the top row, if I take 0 times -2/5, I'm still going to get 0. Added to 1 is going to leave me with a 1. That is why you take care of that first column first, so that you don't have any recycling of numbers that comes through, and then you have to redo all your work again. So it helps you not go in circles. If I take 1 times -2/5, I will get -2/5. Added to +2/5, I will get a 0 in that column. Okay, again, so we went from 2/5 to 0. All right, now in the last one, if I take -1 times -2/5, I get +2/5. +2/5 plus 13/5 will give me 15/5, which when I simplify will give me an answer of 3. So this is telling you that x is equal to 3 and y is equal to -1. So let's just double check our work and make sure that we're correct. So here's my check. So if I take 5 times 3 plus 2 times -1, do I get 13? So 15 minus 2 is 13, so that one checks. Now let's make sure it checks in the second equation. If I take -3 times 3 plus -1, do I get -10? So -9 minus 1 is indeed -10. So I know my solutions are correct because I've checked them algebraically. Other thing that you can do is you can put this in Desmos. You can put the 2 equations into Desmos, one on each line, and where they intersect is going to be their solution. So they should intersect at the point 3, -1.